So I thought I'd do a video on the method and how to modify a method. So from the mandatory prac, how to go and modify a method. So the mandatory prac, if you remember, we had our initial experiment that we did in class, and we had a block of wood that looked something like this, and sitting off the end of that block of wood we had a clear plastic tube. Looks something like this, I guess. Let me continue that through. And what we did is we had a person sort of standing here, and that person was holding the end of the tube, and they were sort of standing up, I guess, and they rolled the ball bearing from here, went down through the tube, and it flew out the end of the tube. And from the end of that tube, then we went and measured the height. The distance the ball bearing went. We measured the distance, and we measured the time of flight. And we varied this a little bit by changing this angle of the pipe. So we held it, against your throat, and we held it against, we changed angle again, and we measured, held it up against your head. And each time what we had to do was make sure that the pipe didn't do this. So if the pipe had sort of curves or whatever, as the ball bearing would go down and it rolled down, it would then hit in here, and that would remove some of the kinetic energy. So we had to make sure that the tube was actually nice and straight, and it had a good, clean, smooth curve for it to exit out of at the other end. Remember, we want to make sure that all of the gravitational potential energy here, so GPE, is equivalent or transformed into the kinetic energy down the bottom here. Now, obviously, it's not going to be 100% efficient, but the more bumps and stuff that we have in the tube, the less efficient that is. And we're trying to make it as close to 100% conversion or transformation of GPE into KE. And we can't do that if there's bumps in there. So we needed to make sure it's nice and straight. We also could have varied the end of the tube, the angle of exit at the end of the tube, and measured how far those ball bearings went on that as well. So you've got three types of modifications that you need to do now. So remember, you need to now modify the experiment. And there are three types. Number one is to redirect. Okay, so we can redirect. And let me just give us a bit more room here. I'll grab that if I can and get it out of the way. And I'll just pause the video and move that out of the way. Okay, so we're back, and we have three modifications. One is a redirection. Another one is a refinement, a redirection. Second is refinement, and the third one that we could possibly do is an extension. So 3 is extension. And what are these? So the first one, a redirection, is where you actually go and change the variable. So in the case of what we had here, the variable that we were changing was the GPE. We were changing the gravitational potential energy by changing the height that the ball bearing was dropped from. So we dropped it from various heights, and then we just measured how far the ball bearing flew when it came out of the end. So we could redirect it by maybe changing the angle. So change theta. And by changing the angle, that means that down at the bottom here, let me get a different color, down at the bottom here, this angle at which the ball bearing was ejected from, that angle there we could change. That would be a redirection. The other thing that we could potentially do, we could, I guess, have a look at the mass of the ball bearing, because we know that GPE is equal to mgh, or mg delta h, and we can't change gravity, but we could, I guess, change the mass and see if the mass has any effect on its kinetic energy, or the gravitational energy, and then the kinetic energy, and what effect that does on having on the projectile's range. Another thing that we could do, another thing we could do is refinement. Now, the refinements, there's a lot of refinements. We'll come back to that maybe last. And the extension is looking at extending the data. So we extend the range of data. So we've made conclusions about the projectile motion, or the projectile's motion as it leaves the tube. But we've got data for, maybe this height and this height and this height and this height. So it might have been, above the head height, throat height, chest height, and let's do another one, knee height. But we could extend the data by actually changing collecting data in between those samples as well. That's an extension. Or we could go outside of the data and go further than the data went previously. That would be an extension as well. Another extension that we could do might be, what would be another extension? Okay, let's leave the extension. We'll just leave that as those, I guess, because I can't think of any more right at the moment. And let's look at refinement. So the refinements are how do we increase or improve the accuracy? Or how do we increase the precision? So remember, accuracy is the error, reducing or increasing error, which is how close your data is to what should happen, what is expected. And the precision is removing the variability in your results so that all your results are tighter cluster, have a tighter cluster. And so, for example, if you're measuring the distance, you're decreasing the range of your distances that you measured. So how do we increase the precision or increase the accuracy through refinements? Well, a lot of these things are going to be your plus or minus accuracy, and a lot of those will be due to measurement. So more specifically, how do we improve the measurements? How do we increase the accuracy of our measurements? So what measurements did we do? Well, we measured the change in height. That was one measurement. We measured the time that it took, time of flight, so TF. What else? We measured the distance or the displacement or the range, so R or X, the distance that the ball bearing actually traveled. We also measured the mass of the ball bearing. We also measured the impact. Let's call that the impact crater. And look, I'll leave it at that, but there's lots of different things here that you could go and vary. How could you increase the precision of the change in height? So you're measuring from here to the bottom of the tube. That's your delta H. So the bottom of the tube where the ball actually exits. I'll draw that a little bit crooked. How do we increase the precision of that change in height? How do we increase the precision of where the ball lands, which is the impact crater? How do we increase the precision of the mass of the ball bearing that you drop through the tube? How do we increase the precision of the distance that you measured for where the ball bearing landed, which is X, or which will ultimately become R for range? How do we increase the accuracy of the time? We use a stopwatch. And how do we increase the accuracy of that stopwatch? How do we increase the one that I didn't write there? How do we increase the accuracy of the angle that we measured? These are all things that we're going to that we can look at to improve the accuracy and ultimately, hopefully, the precision and hopefully ultimately the accuracy through refinements. So it's your job now. I would be probably at this stage for your first EEI would be focusing primarily on these ones. So focus primarily on the refinements to increase the precision and or accuracy of the experiment.